Okay, so the second way to do this is the borrowing method. Because technically what we have here are two different math problems, right? 2 minus 1 and 1/3 minus 2. What is bigger? 1/3 or 1/2? If I'm going to give you a candy bar, would you rather have a third of it or a half of it? Yes, ma'am. A half, right? That's bigger. Do you remember back to first and second grade when the bottom is bigger? Bigger bottom what? What do you do in subtraction when you don't have enough on the top? Bigger bottom borrow. Yeah, sorry, it's taking a minute for the flashback to kick in there, but yeah, it's bigger bottom borrow. If we've got 1/2 on bottom, that's bigger. We can't subtract that from 1/3 without getting a negative number, can we? No. So let's find our common denominator and see what fractions we're really working with. And again, it's just like it was on the first one. We know our common denominator is going to be times something over something equals something over 6, times something over something equals something over 6. 2 times 3 is 6. 1 times 3 is 3. This is all stuff by this point most of you guys are doing mental math. 3 times 2 is 6. 1 times 2 is 2. So now we've got a really messy dull marker that's not working right. Now we've got 2 sixths and 3 sixths. So I'm going to erase this mess and work with just our sixths. Two sixths and 3 sixths. So we have a bigger bottom borrow. If we did the subtraction, we'd get -1 over +6, which is unmath. The universe would explode. Doesn't work that way. But what we can do is get rid of this 2, make it a 1, and add this one over here, right? Just like if we need to borrow in a regular subtraction problem, we go over to our next place value, we take 1 away, and we bring it to the place value smaller. We take 1 out of our holes, we turn it into a new fraction, and we get 8 sixths. Put a little box around it here. Minus 3 sixths. What's 8 minus 3? What's 1 minus 1? So what I have is no holes and 5 sixths. Do our answers to our 2 problems match? Do our answers to our 2 problems match? Yes. If we solved it 2 different ways and got the same answer, does it have to be right? Absolutely. We're good.